So this is like a practicum workshop type. We're going to actually get our hands dirty writing code. That said, I've already written the code, so you can play along or download the files, kind of up to you. But I'm going to set the stage a little bit before we get going with like coding. The task that we want to look at comes from the data set called MBPP, mostly basic Python problems or programs, something like that. We've seen this data set come up multiple times in papers that we've been reading. So I figured let's actually work with it and try and train a model on it. If we look on Hugging Face what MBPP looks like, we have a text feature that is the command, write a Python function to remove the first and last occurrence of a given character from the string. So this is kind of your doc string. You have actual code that's associated with it. So this is a sample solution for the prompt, but not necessarily the only one. And then there's one or more test cases. And these are just simple assert statements where you check to see, is it passing the basic expectation? And this is the data set that we will use for everything going forward. We have 974 rows. Those are split between test with 500, 374 in train, 90 in validation. I'm not actually sure what prompt is. Does anybody know? Yeah.
It's for when you few shot prompted.
Oh, these are like the suggested.
No, these are the ones that they use in the paper and have used in every single MBPP evaluation since, essentially. Just they randomly select 3. I think for POM it's hard coded as the first 3, I want to say.
Okay.
And for POM 2, it's same.
So this is your ICL set of sure. That seems like a weird practice, but if they do it, they do it. So okay, this is our data set. I want to direct us to a tool that I've found some success with, but also strongly detest. This is a tool called Ludwig. Ludwig is, it makes declarative programming for AI very simple. Effectively, we will give them a config, a YAML config, that says, use this model, quantize it this way, train it this way, here's how we want it to all look, run, and it will do the rest. So we abstract a lot of the inner workings of the LLM to make our lives a bit easier. The downside is I don't really like their APIs, but they do make it quite easy. So we can either start from, they have a little open and collab button on Finetune Llama 2 7 billion, or what I recommend is you can go to peaster.dev/638. This is my LLM class, and on here I have 2 links. One of them is trainludwig.ipynb. One of them is traingpt.ipynb. And so you can download each of these, and we will be using those. But these are kind of like the answer file. I didn't have time to delete all the code inside of it to turn it into an assignment, or an assignment. So you could either start from scratch or grab one of these. I'm going to start with one of these. So if you download that and you go to Colab, this is just Google Colab, where everyone has a free account. Free accounts allow you to typically have access to a GPU with no extra strings attached. They're around 15 gigs of memory. That's an NVIDIA T4, which is going to be enough for our task. I did use all of my allotment for a T4 earlier this week, so I actually signed up for Colab Pro, but you probably don't need to, depending on how often you're using it. So if we load in that train Ludwig file, and the text is quite small, let's make it bigger. The start is quite straightforward. We need to set up our environment. In particular, we need to set our Hugging Face token. So where do we get the Hugging Face token? If you go to your Hugging Face account, you can create an access token. I have a Colab token that I can just copy in. And then if we, I'll restart the runtime so that we're starting from scratch. If we run this, the reason that we have to use this token is because Llama is gated on Hugging Face to accept their terms and conditions for using it, so you aren't abusing or mislicensing it. So you have to provide a Hugging Face token so that you can download it. If you want to use a different model, you won't need to do this. Tell me to slow down at any time if I'm going too fast here.
Sorry to interrupt.
Yeah.
But, could you explain where that train Ludwig file was again?
Yeah, so the website is PISTER. It's very small to see there. We can put it on the, put it over here.
Thank you.
Yep. As a quick advertisement, this class is being offered next semester as well. As grad students, you aren't technically allowed to enroll, but there's nothing stopping you from showing up. All right, so going back to train Ludwig, we've set up our Hugging Face token, and that's actually most of all the setup that we need to do. We're going to install Ludwig. We're going to install datasets. That's so that we can download the MBPP dataset. This will take a second to install. After we've installed the libraries, the next thing that we have to do is to actually download MBPP. So we can do that. Some of these steps might go a bit faster for me because they are cached on my computer. But we can then inspect the data set and we'll see that we have everything that we had at the start of when we were looking at Hugging Face before. We have text, code, text, test list, for example, split into train, test, validation, and prompt. And we could inspect any given row if we wanted, but we'll kind of leave that to actually happen later. At this point, the important thing is we've downloaded our data set. Now the next piece is the Ludwig piece, where we actually establish our configuration. And so I want to spend a little bit of time describing what we are saying in this declarative config. First of all, we're talking about LLMs. So our model type is LLM. The model itself is going to be the Llama 2 7 billion parameter model that's been formatted for Hugging Face. This means it's been converted to the right tensor format so that it's easy to work with. Our input features is just text. We have a single instruction that is of type text. Our output feature, I have called it code because we want to write code, but it's just text. The type is text, text in, text out. The actual prompt that will go around our input text, we could put anything here. I've just given some simple example. Below is an instruction that describes a coding task. And then I have a variable here that will be filled in every time we take a training step. So we will go grab an element of our data set, get the text column that was the command, and we will fill it in right here into our instruction. Yeah.
So I think like from intuition, the text should be something like instruction.
Sure.
One like if you have different type of inputs, you want to like concatenate.
Yeah. So we could call this anything. This is just a variable that we will fill in later as we are training. So if let's change this to instruction to be a bit clearer, and then we'll need to make one other code change later on as well. And then after you have done the instruction, here's the response to then prepare the model to generate the response. These are completion models. Every LLM is a completion model, whether it looks like it or not. So what we have here is setting the model up to generate the response. We set a few hyperparameters. We say, temperature, use 0.1, sure. The maximum number of new tokens to generate is 512. This comes from our data set. We could look at the distribution of length across the code to try and figure out what's a good amount of text to generate. 512 seems fine. We're going to use LoRa, which we have looked at. We read that paper, to train. We're going to quantize the model down to 4 bits, and this is a very important step in order to actually train on a Google Colab instance. If you have a more powerful GPU, you would not need to. A few more random hyperparameters to set, however you want to do this. This is for actually splitting your data set, which doesn't matter for us. We've already split our data set. And then we want to do 1 epoch training with a batch size of 1. We want to evaluate with batch size of 2. We could probably bump that up. Accumulate your gradient every 16 steps to pretend we have a batch size of 16. And then set your learning rate and all this. So we've configured our model to learn. We need to actually load it, which is what our Ludwig model with the config will do. We load it in. This step doesn't actually download anything. It's only preparing everything to be loaded. So it shouldn't take a long time. And then we have our model. And if we look at it, we should see it's a Ludwig model. Cool. I can pause here if there's config-related questions.
I have a question.
Yeah.
So you're taking a step by step. Where are we going to get to today? What is the goal?
Yeah. Oh, sorry. Yeah, the goal is we want to train this model to better accomplish this task of taking text in and generating code out. So we are fine-tuning Llama to do code generation. Okay. Yeah.
And so now you loaded it, and now you're going to do LoRa. And then,
Right. So these are all the steps to prepare for the actual fine-tuning. We can then set up our data sets. This is one of the things I don't like about Ludwig is that everything's data frames. They don't connect with the actual data set library. But all that we're doing is grabbing the columns that matter, our text, our code, and our test list. So our train and validation are set up. And then all that we have to do is train. We do a .train on the train data frame and the validation data frame. Before we go there, though, I think it's important to establish how well we are doing before you fine-tune. How good does the base Llama do at solving MBPP? That seems like a fair question to ask. It's also something that's a little tricky to answer with the Ludwig API. But I did run through this where basically I just gave it the instruction and said, try and generate code. And what it outputs is, as you would expect, kind of the traditional nonsense of completion models. If you haven't prompted them properly, it just continues to generate instructions. Every now and then it will actually write a good function. So for example, here's a response where the base model was calculating the perimeter of a rectangle, I guess, or a square. So I have stats on this that we'll see later. But for now, let's just click train, which it's mad at me. What did we do wrong? Oh, because we didn't change our data set after changing our... So if you made the same change that I made, where you change instruction, this used to be text, then you would need to, over here as well, specify that instruction is the variable that's going to be passed in. And now if we train, we get lots of output. And the output starts by kind of telling you about your experiment. It shows you that you have established your random seed, tells you what the torch version is, that you're on CUDA, that your data set was a data frame. Great. Goes through all your hyperparameters. And then, depending on if you have previously run this, it will start downloading the model, or it will just start loading the model from memory. So if you have it saved on your disk, it will just start loading as it is doing here. Otherwise, it will start downloading to Google Colab. This takes like 45 seconds or so. Other questions at this point that I can answer?
So sir, I have a question of the column into
Mm-hmm.
the data frame.
Mm-hmm.
So there is a column into code. So what the code is correspond to the input, the compute file.
Yeah, so code, down below, we have code here. This is our answer. This is the solution. So we want to train the model to, given this, predict that. Generate the code. How this fits into the config is that we specified our output feature to be named code. And that's actually all that we have to do. Ludwig figures out the rest, that that's the thing to try to match in the model and train the model to do. So yeah, there's some variable names kind of like scattered throughout here. We have the code piece here and the instruction piece here. Those are each coming from the column. And the test we're ignoring for now, but will come back to be important later. Yeah.
Thank you.
It looks like I fully loaded the checkpoint here, which means I've actually started training. And so you can see training has begun. It's training across 373 steps. That's 373 because our train has 374. So something got lost. I don't know what. So it's going through every row of our train data set. And it's only doing it once because we specified epoch size of 1. So we go through exactly once before we've finished training. Some other things to call out here. We have the trainable params are roughly 4 million out of the 7 billion that are in the model. This is what we would expect because we're doing LoRa. We're updating 0.06% of the params. I was expecting some downtime as we were waiting for things to train. So I asked GPT-4 to write us some jokes. The jokes are horrible. Why don't programmers like to go outside? Because they don't like Java. What does that mean? This one at least makes sense. Like, the computer was cold, it left the windows open. And I like the recursive reference, like, couldn't get out of the shower because it said lather, rinse, repeat.
Oh, that's very good.
But like, why do Python coders prefer snakes? Because they usually Python a show for their coworkers? What does that mean? Anyway, did we finish training? Not yet. So I told it did a bad job. And it tried to come up with some better jokes. It said humor's subjective, though, so maybe I just didn't understand the jokes. Why don't programmers like nature? Anybody have an idea? Too many bugs?
Oh my god.
All right, now we're probably done. Or thereabouts.
So So did you choose the number of epochs or? Like,
Yeah. That's all part of our config up above. We say, just do one.
but the 373, where does it come from?
That is from the size of our train data set,
Okay.
which is 374. So one of the train rows got lost. I don't actually know why. It should be 374.
So I know I was getting an import error when you're trying to train.
Yeah, I forgot to request it. Maybe you have to request from other things.
No, I have that. Saying I don't have other libraries that are actually.
Which import error?
It says that I need to do pip install accelerate and pip install bits and bytes.
So,
I've done that and they were already installed.
You have the like LLM specifier with Ludwig. So you might have to restart. Are you on Colab?
Yeah.
Okay, so you might have to restart your runtime, and you don't import those things at the start or something. Because sometimes if you import it first and then pip install, it gets all confused. But if you're just doing the same thing here, it should work. Yeah. I don't know. That seems weird. You could try using the it comes up later in here for a completely different purpose, but there's import lib allows you to reload an import. So you can import lib.reload to try and reload accelerate. After you do like a pip install accelerate, or if it's already there, just do a reload on it. Other errors that you guys are running into at this point?
But we'll see.
Okay.
She said that she rerouted it, she didn't get it, so.
So we finished training, and this is actually kind of the boring part, if you will, because we're talking about code. And so we actually want to do a lot more than just generate. We want to test. But we can see the output summary that we got from Ludwig. It says, look, you trained, you reduced your loss. Perhaps this is meaningful. Because we don't have a good step one, it's not the most helpful. But when I evaluated base Llama, it did very poorly, and we will see that we get a little bit better as we have trained. Once we've trained, the next step is actually using the model. So what I've done here is I say, go get 20 rows of the test data set, and then pass them into the model.predict. And what this is going to do is run our model on the data set that it's never seen before to try to actually see how well it's doing. So for example, write a Python function to remove the first and last occurrence of a given letter from a string. The response that we get here looks like it's going to be wrong. Remove first, last, string, character, replace character with empty. But we can see that we are generating actual code as we are running this. Some of it is like nonsense though. Like why our response here is nobody, set def, self. So our model is clearly learning to write Python code, but it's certainly still running into issues.
So wait, what are you trying to, what is this?
So we are predicting using our fine-tuned
On the
model
test set.
on the test set. Yep. And then there's a lot of output here, but the thing to look for is anywhere you see response.
Mm-hmm.
So the instruction was write a function to sort a given matrix in ascending order according to the sum of its rows.
And so this was in the fine-tuning training set.
Test set.
The test set. So this is it left out.
Yes, it has never seen this
Okay.
command before.
Sorry.
Hypothetically, assuming that Llama was not trained on any of this. And so then it generates this snippet right here. And we can see this keeps going. We're generating lots of code for the 20 test set examples. And then we get to something interesting, which is this idea that now we have code and we have test cases. How do we actually run our test cases on our code in a programmatic way? Because we could have 20 generated examples, or we could have 200 or 5,000. We want to run that code and test it with our test cases, our assert statements. And what I came up with, which could totally be the wrong thing to do, and so I'm curious if somebody knows the right thing to do. But we're going to go through all of our results. We're going to say what was the instruction, what was the output that we generated, and then we're going to evaluate our code on the test code, or on the tests. And evaluate, if we look at what this does, is going to, the key thing, we're going to write to a temporary file the code that we generated. We're going to write the test cases that that were provided to us. We're going to reload that file to import it. Assuming that the load succeeds, that means none of the asserts failed, which means that we passed all of our test cases and we can return true. If we catch an exception, that means an assert failed, and therefore we should return false. I can't imagine this is what OpenAI is doing. So
here you're just like loading, you're just testing if the solution is correct.
Right. Ideally, what you would say is something like eval code response, and then for test in tests, like eval test actually is something like what you would want to do. But eval in Python is neutered in that it can only eval expressions. You can't eval statements. So things like def or x equals 10, you can't do. So the workaround that I have found is building my own file eval, which we say write it to a file, reload that file, assuming that there are no errors.
I understand when you join the test, what does it mean? Like you run it on the input?
Yeah. So I'm writing the test cases to a file here. These are things like assert that function of x of 3 and 2 equals true. It's things like this. And so you have a list of them, you write them all to the file at the bottom.
So the way that OpenAI does it specifically, they use that eval you mentioned.
Yeah.
Then they'll just join the test to it there and run it in there. The way that we've done in the past is that we have written just temporary files like this, but then you can essentially emulate the command line through one of Python's libraries,
right,
and you can run it through that rather than doing the imported method as well. But this works.
There you go. Yeah, that's what I found as well, that it did work. It just felt like I was doing it wrong.
Probably you need a sandbox to protect the...
Anyway, we trust OpenAI.
Yeah, definitely this is not great from a...
some code that tried to remove some files and...
Well, so the sandbox here is that I'm on Colab.
Oh,
yeah.
So it's not hitting my file system, which is good. But yeah, definitely, like if you're doing something like this, you need to consider the security implications of it. So when I ran through on the default Llama with this test framework, it passed 0 out of 20. I only ran it on 20 because they take about a minute for the default Llama to generate. Whatever, you could speed it up. I wrote this in just an hour or so. But we've probably finished generating our prediction, which means we should be able to evaluate on our fine-tuned model. So we have, if we look at it, predictions is this long list. It's got 20 elements of it that are the code generations that went that came from our 20 instructions. So this is our test set. We have generated a bunch of code according to our test set. And if we actually evaluate it, it should take just a second. Oh, we don't have text again. We have instructions. Everything else should be fine. We can see that the success is 3 out of 20 after we have fine-tuned. So before fine-tuning, 0 out of 20. After fine-tuning, 3 out of 20. That's a 15% point improvement. But it's still pretty poor. And I would expect this is because we are using a 4-bit quantized Llama that doesn't have a lot of understanding of these things.
So the distraction, so after you did so this gave you the accuracy of what?
Right, so this is saying how many passed all of the test cases.
Okay,
But this is best at 1. So we only generated a single example. We didn't generate a bunch and sample and say, if we did 10 different ones for each question, how would it do?
So it's 3 out of how many?
3 out of 20.
Okay.
Like, maybe we can check whether we already fit overfit on the training set.
Yeah, definitely could be that we're doing 370 steps, or alternatively, maybe we needed a second epoch of training. It's hard to say.
Well, that part is easy to say.
Well, you have to actually run it, though.
Yeah.
Hard to speculate on. Yeah. Easy to do. And so at this point, we fine-tuned Llama and evaluated it in terms of how well it can write code to pass our spec.
What was the passed one before this?
0.
Okay.
Yeah, with base Llama, Llama 2, it was 0. I was a bit kind as well and did a little bit of prompting for the base Llama, and it still got 0. It was just not very good at it. So this was fine-tuning Llama, but let's actually say that you want to do something that works and play around with GPT instead. Or we can spend more time with Llama. Does anybody have Llama questions? Or things, errors, things to help? Okay. I think we should do another interesting one then, which is fine-tuning ChatGPT to solve the same task. So the setup is going to be very similar. We want to import datasets, download MBPP, and then install OpenAI, and sllim is how I recommend you interface with OpenAI. We can set our API key for OpenAI, which you will need to get from somewhere. I copied over the same evaluation harness so that we can test the pass rate on our test cases. And then the simplest thing to do is to just chat with ChatGPT. Say, let's talk to 3.5. What I'm doing here is for every test in our test set, up to the first 20, because that's what we evaluated before, we could do just as many. I want to chat where I'm passing in a system message. So write only code, stop when you finish writing the function, a small amount of prompt engineering, because we aren't fine-tuning or anything like that. Pass in the actual text that is associated with our instruction, and then give it the backticks to say you're writing a multi-line code. Parse the response by stripping out any of these backticks and grab the first code block, and then run that same evaluate. And when we go through this, we see that we are actually passing 9 out of 20, out of the first 20. So ChatGPT, with no fine-tuning, all that I've done is provide a system message that says, write code, gets 9 out of 20.
Wait, where do you tell it what to solve? Oh, the text, okay.
Yes, so we grab that same feature, the text feature, and pass it all in. And this is all that we need to do to run the same experiment, but with ChatGPT. We could also change this slightly to say model equals GPT-4. I don't actually know how this one will do. It'll take a second to run. And we can see sllim is giving us logging, saying here's what we're passing to GPT. That's the instruction. here's what it's returning back to us. That failed on the tests, or the other one passed the test, this one failed on the test. We're going through the first 20 again here. And it'll take a little bit as it generates all of them. sllim is a tool that I wrote because I interface with OpenAI a lot. And OpenAI's library is pretty bad from a usability perspective. And all the others are also pretty bad. LangChain is just a nightmare to read. So sllim is kind of nice.
Can you, I'm curious, if you can try to change your 3.5 version to when it fails. So when it fails, do you get the error message or you just say fails?
Sometimes you get the error message. It depends. So the asserts don't tell you why.
No, but like your eval, right now, what are you getting out of? How are you collecting how are you doing the sandboxing? Can you show me again?
Yep. So GPT-4 only passed 8. Chat GPT passed 9, or 3.5 passed 9. So we find the function names because the function names are arbitrary.
Yeah, I want to see just the exception. So can we do the exception? Can you print, instead of fail on test, can you add the exception?
So the issue with this is that the exceptions aren't, if you fail the test case, it doesn't tell you which test case you failed or like
I know,
why.
But I just curious if we add, let's say the first 1,000 characters. So that's maybe, I don't know what's your GPT budget.
Yeah.
Let's say we pick the first 200 characters.
So
I want to record the characters.
yeah.
And now I want to, when it fails, before giving up, I want to ask it first to try to fix the error.
So we want to return this as well then.
Yeah, I want to return the first 100 characters. Of that and false. And now
So let's change our code a little bit to say that messages is equal to this.
well, you're saying to record it's true or false.
And we want to chat with our messages. Response is that, and then we can say messages dot append the response.
Okay, you should prompt the engineering to just say, can you fix this error?
Yeah, but we need to add the actual response as well.
Okay.
So this is what, so we're building a history now.
Okay.
We start with the system and user, then we're going to add the assistant, the response that we get. Then we can add a whatever we get here. So we're getting the message.
Guys,
Yep.
do you know how to give a custom endpoint for
To like custom model.
No, I'm just trying to connect to AI. We're trying to use our labs. Is there an AI?
Are you using sllim or OpenAI? So you can set OpenAI.API base
Okay.
and pass in the whatever the key thing is.
Key there.
Not the key. The key
Yeah.
stays the same, but it'll be whatever your endpoint URL is.
Okay.
Yeah.
Rather than going to the defaults and look at it.
Right.
Thank you.
All right. So if the result was false, then we want to say messages append a user message saying, "Here's the error."
Just say, can you fix this error? And let's say for now we just do one attempt. So
Something like this, right? So if we succeed the first time, just skip all this. And if we don't succeed, then do it again. I don't think that we have error messages on most of them. So yeah, for example, here we fail on the test, but no error message comes out of it because we've just failed an assert silently. Some of them, it could be that we get more information.
What were we at before?
9. With 3.5, we had 9. But then we have to actually output count. Count? It's not score. Still 9. So that didn't help us pass any, but maybe we could say.
Probably the easy fix for it to output the assert. You need the assert statement.
But then that's cheating.
Yeah, you know.
Right? It feels like it would be cheating if you start saying like you failed on an assert where.
Can you just show can you print the message at each point? Can you just print the message when you get to
this message?
Yeah,
or
not the MSG.
It's blank most of the time.
No, but, it wasn't printing it at all.
It was printing actually before. Up above, anytime you fail. Oh no, it wasn't printing before.
Yeah.
That's also printed. Yeah, but it is blank most of the time.
If you do the eval method, then you'll get the exact error message as well.
But it's an assert error. There is no error.
Yeah, they'll still say assertion rather than they'll give you an exception that you can now use, right? They'll give you the exception object that will sometimes include.
Okay, so at least it catches the undefined functions.
Mm-hmm.
But it didn't fail. Well, it actually fixed that one. Did it? Oh no, it still failed on test, but then it failed again as well.
This one, it looks like it
No,
succeeded.
I think he failed twice instead of like he didn't fix the error.
Yeah, our score hasn't actually changed.
Alright, yeah, I was just curious.
Yeah. So all of this then, like this is just standard, prompting. We're doing zero shot. We could also fine tune 3.5 these days. So we could save our data set to a JSON-L file. This is what OpenAI wants. If we run this, what we will see in our folder is that we save this JSON-L, which we can open up. And we can choose an application. And the JSON-L here is a big list of all of our training messages where we have like user and whatnot. The user says, here's a request. The assistant then provides code back. So we've saved this long list to a file. We can then use the OpenAI library to upload that file to their service, which you can run, and then create a fine-tuning job on 3.5 using that file. And then you can check the status. And this normally takes a while, so I ran this previously. It looks like it did succeed. This had taken a bit, though. And you end up with a fine-tuned model for 3.5, which we should be able to plug right back into our messages and see into our requests. And we should be able to see that we have an update. It should say down there. I don't know. It's typically like pennies, but does it actually tell me? Trained tokens is 91,000. What is it per? It's like a few cents per 1,000 tokens, right? So might have been $3. So I don't know that fine tuning was the right way to go versus, oh, well, it's because we are prompting it still, at least. That's something we should not be doing anymore now that we have fine tuned it. Let us just do the text. So you can see some of the errors are actually Python errors. List object has no attribute values. Some of them are blank where it's just failing.
For those one, it says Python not defined.
Still 7. So we're only looking at 20 of the 500 test case examples. I'd be curious to see how this expands as we, you run it up to 100 and see what changes. But
We can't afford it.
well, I mean, it's more a time thing, right? But that is how you would then be fine tuning 3.5 or Llama. Yeah.
We're just little kids here.
Yeah.
With that endpoint change, it doesn't like the way to specify chat. How to address that?
Using sllim, like this chat here.
Not for read there.
It's possible you need to pass engine instead of model.
Yeah, I think that's the problem.
Yeah, just
We'll find which model we're using.
yeah. The OpenAI API is really, really annoying.
You said that earlier, now I understand.
Yeah, it's like it is usable. It's technically usable, but their documentation is minimal, and they're it's quite annoying. But we kind of solved the same problem 3 or 4 different ways there. I think the one that we didn't do is if we go back to what we had, but now we start using in-context learning and we say, let's grab our data set at prompts, because that's what it's for, apparently. And we would want to format these and then add them to our messages. Something like this. And then we can see how that would perform. But that's the kind of the options that we have, right? We do something like this, right? Now we've done in-context learning as well. very briefly there. If we just grab the first 3 elements of our prompt data set, add those as a base message to include with the system message.
Do you pay per generation or per token you feed to the model?
Per token fed and generated by the model, yeah. But really, it's the generation, because that's where you waste your time. Oh, we improved our score. Yeah, cool. That's kind of all I had. So I'm happy to keep chatting, but or experimenting. Yeah. Yeah, either way. That's all I do all day anyway.
Other questions?
So I tried to use another model like other like Sarcoder 7 million.
Yeah.
And then when I downloaded to Colab, it said like it's crashed after using all the RAMs.
Yeah.
So I wonder like what's the difference? Like I mean, they are the same size of models, and I'm using the same size.
Quantized to 4 bits.
It could be quantization, but it's also the prep by Hugging Face to convert it to safe tensors. There's optimization in how you load the model as well. That if you just try to download an equal size model, it's not necessarily going to work. Yeah. Yeah, I was trying with Mistral to see if I could do that, but it's not quite there, unfortunately. In order to fit on a collab, that is.
The third one is very bad.
Which one's bad?
The third one is very bad.
Oh, yeah. I liked this last one. What's the most used language in programming? Profanity.
I don't think it's original.
No, I mean, I'm sure none of it is.
It's not known for accuracy.
Yeah.
Okay.
Cool. That's a whirlwind tour into training a model or training GPT.
Thanks. Wait, so in next